and welcome to Chemistry Nuggets, where you can polish your knowledge and clear your doubts. So friends, today's video I am going to discuss inductive effect. What is inductive effect, where it is used, and what it helps in our organic chemistry. That points we consider in this video. So let's start the video, but before starting, if you haven't subscribed to the channel, please subscribe so that you can get the notification for the next coming videos. So whenever a reaction starts, there will be a substrate. And this substrate will give a product when a reagent is there. So a substrate, when a reagent is coming to the substrate, they will do some kind of reaction. Intermediates will be there. That reaction intermediates will proceed to the product. So the point is the reagent, where the reagent attacks the substrate, at which point. This is very important thing, and this only we will understand by the inductive effect. So let's start inductive effect. First we will check the definition. The inductive effect refers to the polarity produced in a molecule. Polarity produced in a molecule result of the higher electronegativity of one atom compared to another. So suppose we have a compound. This we have a compound. So in this compound there is a electronegative atom. We can see easily chlorine is electronegative as compared to the carbon. Okay. So in this case there is a sharing of electron to make a sigma bond. Simply one electron is coming from the carbon, one electron is coming from the chlorine to make a bond, covalent bond. Now in case of inductive effect, what is going on? This pair of electron slightly shift towards the chlorine because of the electronegativity. What is electronegativity? The tendency to attract the electrons towards itself. It's called electronegativity. When chlorine is an electronegative atom, it means it has a power to attract the electrons. So what it will do? It will attract the shared pair of electron, and it becomes like that. The bond will not break. The electron pair will shift slightly towards the chlorine. Because of this shifting of this nature of chlorine to attract the electrons, chlorine will acquire a slight negative charge, that is called del minus. And because of that shifting, again carbon will acquire a plus positive charge because it has a less electron than it can have. So this partial positive charge and partial minus charge, or we can say this kind of partial polarity of electrons between the two elements in a compound is called as inductive effect. Now what is the use of this? The use is when there is a compound like this is going under through a reaction mechanism, and we will send a nucleophile as a reagent. The nucleophile will go and such what nucleophile is acquiring a minus charge, so it will directly go and attach to the positively charged carbon, which is already positively charged due to inductive effect. Now if we send an electrophile which is positive charge reagent, where it will go? It will search a negative charge position, that is chlorine already. So it will go and add up to the chlorine. So this is kind of thing going on when we are sending nucleophile and electrophile. So inductive effect is very important part of our reaction mechanism. Now, what is going on if we have simple like CH3, CH2, CH2 and Cl? What is going on here? Shifting of electron towards this. So this will become Cl. It will acquire minus delta charge. It will acquire minus positive charge, plus delta charge. So electron shifting is towards it. In this case, the carbon will acquire positive charge. It will again ask for the electron from the next carbon, and in this way, carbon is trying to satisfy its positive charge to become stable. So what will happen? The next coming carbon is also having a minor plus charge because the electron shifting is occurring. So it will get very small amount of positive charge because of the positively charged carbon which is attracting the electron from the next carbon. In the same way, electron shifting occurs and the next carbon also acquiring a very small amount. Double delta means smaller than the delta, and triple delta means smaller than the double delta. It means slowly the positive charge is shifting towards the next carbon, but the amount every time is smaller than the earlier one. And it will be negligible after the third carbon. So we will not study anything else next to the third carbon. So this is a kind of a scene is going on in the inductive effect, and we know inductive effect is always in the periodic table. It is on the right side. From moving left to right, the inductive effect will increase, and from moving up to down, the inductive effect is decreased. It means from down to up, it is increased. So when there is a comparison between the right side atom to the left side atom, always the right side atoms are more electronegative. In this way, we will guess which one is more electronegative. So let's come to the some points which are very important to remember. So first one is inductive effect involves always sigma electrons which form a covalent bond. Second point, the more electronegative atom of the covalent bond attacks the shared pair of electron. That we knew. Third point, thus the electronegative atom acquires a small negative charge. That is, we can say del minus or minus delta. The less electronegative atom acquires the small positive charge. That is smaller than the actual charge they can get. The inductive effect is of two types, plus I effect and minus I effect. This point is very, very important. So when it is a plus I effect, if the groups are the giver of electron, those are called showing plus I effect. So examples of plus I effect are methyl group because they are electron givers, or we can say CH2R or CHR2, or we can say CR3. These are all plus showing plus I effect. Okay, so whenever these groups are attached to the carbon and polarity is produced, it means there is a plus I effect shown. The example of minus I effect, all those which are more electronegative than carbon. So it will be NO2, CN or NH3 plus, or we can say so many other SO3 and C6H5. These are all having minus I effect. It means if these groups are attached to the compound, they will attract the electron towards themselves. So these compounds are showing minus I effect. So many questions are asked only from plus I and minus I effect. So this point is very important and we need to study a lot on this topic. The next and very important point is it is a permanent effect. It means it never waits for the reagent to come and then they will show polarity. In the neutral condition also, the compound is polarized, and when the nucleophiles or electrophiles come, they will attach accordingly. So this is all the story about inductive effect. Hope you guys understand the topic very well. So keep watching the videos. Till then, thank you.